Different diagnostic methods for detecting antibody or antigen. Indirect fluorescent antibody, we use plate 12 coated with the appropriate cell line infected with the target virus and incubated for viral growth. Serum sample is added if present serum antibody attached to virus on the plate. After washing, a fluorescent dye conjugate is added, and we put it under the fluorescent microscope and check for the presence of fluorescent. Polymerase chain reaction. Detect antigenic genetic material of pathogen, either DNA or RNA. Target sequence is amplified to enhance detection as the number of cycles necessary for detection. Cycle threshold value, CT value, lower than a limit, more initial target present. Highly sensitive and specific, but extremely narrow target may miss variants that are slightly different. Require continuous field sample monitoring to ensure adequate primer. Serum neutralization test. Measure the presence of neutralizing antibody to a given virus. The sample along with the specific virus for antibodies of the interest is added to wells containing cell culture. The original sample is serially diluted to determine neutralization titer. Sample positive for antibodies attached to the virus and prevent cytopathic effect to the cell in each well. Neutralizing quantitation is the dilution before CBE is identified. Here the negative positive, the control. Here the diluted sample. Serum neutralization measures the presence of neutralizing antibody to a given virus. Generally, high sensitivity and specificity may be too exclusive for general use, need too much work and time intensive. Heme agglutination inhibition test. Some viruses heme agglutinate the RBCs of other species. We use this character to identify some virus like Newcastle disease virus and influenza. Here the virus plus RBCs, MAT plus this is antibody virus, free RBCs. Here this is the positive and negative. This is a positive and this is a negative. Here agglutination occur. The virus agglutinate the RBCs and they make something like a mat. Complement fixation test. Antigen antibody complex bind complement. The complement present in the plasma. ELISA, the most important technique. Here the control negative and control positive. Enzyme linked immunosorbent assay detect antibodies after infection. Antibodies are found in serum, oral fluid, or GIT. Antibody type detect depend on the test design and format. Indirect ELISA, often IgG blocking ELISA. All antibody type IgM, IgG, IgA. The indirect ELISA provide a semi-quantitative range of antibodies level when used routinely. Over time, antibody ELISA visualize the mechanic of a well. Here a well, one well we take from the plate. Here the antigen. We add the serum sample. Either there is antibodies or there is no antibodies. Here the positive result, the antibody is present and attached to the coated antigen. Here we put the conjugated antibodies, which is conjugated by enzyme. We add the color material and the color developed, and we detect under the reader, and an ELISA reader determine the optical density of the color expressed by the sample, and the positive and the negative control. You use it to make some calculation, and the software do everything for us, and bring the result in a form of charts or some tables. We can read the result and make the conclusions or interpret the result. Here the output in index software: sample optical density minus mean negative control divided by the sample positive ratio, and the software use this value, mean positive control minus mean negative control. Here the blocking ELISA, we use the coated plate, we put the antibodies. Here the negative result, in the positive result. When the antibodies is found, it prevents this conjugated antibody from attaching to the antigen, and there is the competition between the two type of antibodies. Less color means more positive. How to compare? We can detect either antibodies or antigen. Some people compare this with someone come to steal your things in your house. If you catch the person himself, this is the antigen. This is the person who steal your something like virus or bacteria. We detect the nuclear material or the genetic material of the virus or bacteria. We use PCR in this method. This person can escape from your house and take your things, but he leave some fingerprints, some of something from his own, something like his keys, something like this. Is the detection of the antibodies by ELISA. ELISA is excellent screening tool, give comprehensive picture of the disease, early awareness of changes, useful overlook health, disease elimination, vaccination timing, identifying concurrent in investigation for specific agent, point in time information, semi-quantitative sample size or buffering influence ability to detect, may decrease sensitivity. Many antigen tests such as PCR can often detect very low amount of target in sample. Also in antibodies, we detect exposure and immune response to target agent, detect maternal antibodies, recent vaccination, pathogen exposure, technically simple, very simple, highly repeatability. We do it 2 times, 3 times, and the result not changed. Real-time detection of the disease agent in the animal flock, the antigen, high sensitivity, may not detect new variant, more technically demanding than ELISA, sophisticated. Antibody and antigen assay detect different target and should not be used as confirmatory test for each other. Early in infection, the target may be present with limited antibody production, but as disease progresses, more antibodies will be present and with a low prevalence of the target agent. Here, we make ELISA and the PCR at the same time simultaneously, and we interpret. If the ELISA and the PCR are positive, the active viremia, we detect active viremia. circulation and infection. There is a infection in this time. If the ELISA positive and PCR negative, previous infection exposure but not evidence of viremia. Or both, if the ELISA negative and PCR positive, there is indication of early infection. Both of them are negative, there is no infection. Thank you.